This video shows how to create a weather report service using IDT tool. In this service, the subscriber needs to send a short message with the specified content, and after the system receives the message, it will resemble the weather report information and deliver back to the subscriber by SMS. IDT also have a name called UC, and it is based on Eclipse. So the first step, we need to create a new UC project. Then name this project. You can also change the location by choosing here, and then click Next. There are some property parameters need to be filled in. For example, the service name. Normally this is the default name using the same as the project name. Now it's demo, and the service ID. This is a unique ID of the service, and if we have multiple services running in the system, this ID must be different from other ones. Provider, just a name of this service provider, the service version, and then finish. So this is the outer layer of IDT tool, and we can see it's based on GUI. In the left side, it's the project information. Now we can see the project named demo. In the middle, it's the functional node, and this common node is provided by the IDT tool. They realize the specific function. Atom service, uplink service, web service can be uploaded using some jar package, and later we will see how to upload these functional modules. And on the right side, this is the editing space, and each time when we create a new project or a new service, there will be a start node and end node as the default nodes. And then we can drag this functional node to the editing space to assemble the service. Now let's see how to upload an Atom service to the system. As we can see now, there's already a CDR build Atom in the system, and also we can able to upload new atoms to the IDT tool. These atoms can be provided by the vendor. Also, you can define your own atoms with a specific function, and we have another video to introduce how to define your own atom. These are the zip packages of Atom service, and now we are trying to load a SMS service to the system. Choose an icon for SMS Atom. Now we can see this SMS Atom service has been imported to the IDT tool. The steps to upload the uplink service Atom to the IDT will be the same. The difference between Atom service and the uplink service, we will take SMS as the example. The SMS Atom service is used to send messages to the subscriber, and the uplink service of SMS is used to receive the SMS from the subscriber. Basically, if the service needs to interact with the database, for example, read some data from the database or write something into the database, then we need to create a data source. Because in our demo service, the message will not only be sent to the subscriber, but also will be written into the database, so the data source need to be created. These are some parameters of the database. The data source name, you can just name it as you want. The database type, we are using Oracle. Then here, this is the IP of the database, the port number 1521, the SID, we name as UDT SEE. Then the username of the database, ZTE IDT SEE, and then the password. After finish inputting those parameters, we can click the test to see whether this database connection works or the parameters are correct or not. So the DB connection is success. Now let's start developing the new SMS weather report service. So this is the basic structure of the SMS weather report service. The start node, it shows this is the start point of the service and it will receive the message from the subscriber. Then the operation 1, this actually it is an occupation node. It doesn't do any operation, just in case that in the future maybe we will do some modification to the service flow. So after we receive the message from the subscriber, we will need to identify the message content. If the message content equals to character Y, then it will go to this direction, goes to operation 2. And in this operation 2, it will assemble the weather information. The weather today is sunny, and actually in the real scenario, we can replace this operation 2 node with an API to connect with Google server in order to fetch the weather informations. But in this demo, we only use this node as a demonstration to assemble the weather information. And if the message content does not equals to Y, then we will go to the operation 3 and it will generate an error message. So we will go back to the normal flow. The operation 2 node generate the weather information and then goes to the Java node. So in this Java node, we will add a prefix hello to the weather information. So the message received by the subscriber will be hello, the weather today is sunny. And then this message need to be delivered to the subscriber using the SMS add-on. And after this, we also need to write the message information to the database by using the database node. And finally, the flow will be ended in the end node. We might need to create some variables which will be shared during the service flow. example, now we create a variable named message, and the type is string. This variable will be used to keep the short message content. So we can see the new variable message has been successfully added. Here the input actually means the input parameters of this start node. So let's think in our demo, what is the input parameter? The input parameter should be related with the short message which is sent by the subscriber. And if the subscriber send a message to this service, then there will be calling number, call it number, and the message content. And of course, there's other parameters included. Here we define an input parameter named the calling, and it will assign the value to this variable calling number. So it means when we're doing the simulation, we will need to manually input the value for calling, and it will assign the value to this parameter calling number. So this parameter will be used to store the calling number of the short message. This input message used to simulate the message content from the subscriber, and it will assign the message to this variable. And as you remember, this message actually is predefined in the variable tab. So here we created two input parameters to simulate the short message calling number and the short message content from the subscriber. Then assign the short message calling number to this variable calling number. Assign the short message content to the variable message. So later the values of these two variables can be shared by other node in this service flow, so we can determine what the next steps based on these two variables. We use this transition to connect all these nodes in order to demonstrate the service flow. Means it shows the service direction. So here we have two options. One is up here, the other one is down here. Previously we mentioned in the beginning we need to identify the message content. If the short message content equals to character Y, then it will go to the up direction. And if the short message content does not equals to the character Y, then it will generate an error message. We can double click the transition to set the match condition. Choose the router type condition. Create new condition by clicking here. The expression here means if the message's value equals to character Y, then this route will be selected. So in this diagram, it's quite obvious. If the message equals to Y, then it will go to this direction. And later we also need to configure if the message does not equals to y, then it will choose this path. So here, if the message content does not equals to y, then this path will be chosen. So until now, it's very obvious how the judgment is done. Since in this demo we are using this operation node to simulate the generation of weather information, so we rename this as create info. In this operation tab, we will define what exactly need to be done. Here we choose the operation assign. Then the value here will be assigned to this variable. That means the content, the weather today is sunny, will be assigned to this message. And if you still remember, previously actually we put the message content, which is sent by the subscriber, in this message. And now we assign the value to this message again. That means the system will overwrite the message. So now the value of the message should be this one. So the weather simulator has been created. We rename this node as create arrow. Assign the value arrow to this variable. Have a review about the flow function. The subscriber's message will go in from here, step node, and if the message content equals to y, then we will use this create info operation node to simulate the weather information generation. And if the message content does not equals to y, then we will use this create error node to generate an error message. The Java node enabled the developer to define some complex functions which is not pre-provided by the IDT tool. And in this demo, we will use this Java node to add a prefix hello to the message content. Double click it. The new message format will be hello and then the message content. Go back to the main flow by clicking here. Now we will need to define the SMS add-on service. which will be used to deliver the short message to the subscriber. Rename this item as send SMS and keep the action as default. The input parameters here actually means the input variables of the SMS item, and also these parameters will be forwarded to the SMSC. The output parameter here means the feedback from the SMSC. For example, whether the message has been successfully delivered or not. The SP means service provider. The SP ID and the SP password need to be registered in the SMSC system. Timestamp, it can be 8 random digits. For other parameters, such as product ID, service access number, transaction ID, these can be random values. Multicast messaging means whether you want to send the message to multiple users. Here we choose false because we only have one receiver. Addresses, this is the number which we want to send the short message. And in our scenario, we want to send back the weather information to the subscriber who sent the short message request. So the address is here. It should be calling number. Sender name. This sender name will be displayed on the receiver's mobile phone. So in his phone side, it will show the sender is ZTE. And here, this is the message content. So which content will be sent to the subscribers by SMS? It is this message. And we already know the values here. It will be hello plus the weather condition or the error information. So the configuration of send SMS item has been finished. Next, let's see the database node. Here we choose the data source DB test, and this one, do you still remember where we config this? In the beginning, we config the database in here. We execute this SQL, insert the two values, calling number and the message content, into the database table, demo table. Save the project. Until now, the definition of the service actually has been finished. And as we all know, in order to verify the service whether it works normally or not, we need to do the simulation. And also in the IDT, we provide a simulator. As the information shows here, start simulation finished. Next step, we need to deploy the service to UC simulation. So right-click the demo, choose Deploy. From the information here, we can see the deployment is a success. And during the simulation, we can do the debug step by step. So the token breakpoint can be added to those nodes. After config all those breakpoints, we are ready to do the single-step debugging. Right-click the demo, choose Debug. So here we use the configuration here to do the simulation of the SMS message. In the start mode here, because in our service flow we only have one start node, so this normal start is defaultly chosen. And in the flow, if we deploy an uplink atom, then this uplink start will be available. The parameters here, if you still recall these two parameters, actually we define in the beginning. This calling number is the short message calling number, and this input message is the short message content. So in here, we use this part to do the simulation. So it also means there's a short message sending from this number 10086, and the short message content is character Y. Just click yes, or you can also check this remember my decision, it will not inform you again. The flow will automatically stop in the breakpoint. So in this flow, the service started from the start node and then go to the next. When the simulator detects this breakpoint here, then the flow will be suspended, and you can click this single step debug by doing step by step. During the debug, you can also view the process variables in this path. So in our case, we can see this parameter message, and when the flow goes to this Java node, the content of this message already been changed to the weather today is sunny. So after the flow go bypass the Java, then the message content will become hello, the weather today is sunny, because the Java node will add a prefix. And by the way, the breakpoint here means we will stop the flow, and this means this node haven't been executed. It only shows the result of the previous process. So this is the GUI debugging mode. Also, the UC provide the coding debug mode by click this icon to switch debugging code, and then you are able to do the debug and the code mode. also switch back to the GUI by click this icon again. Now the flow has reached to the database node, and one more step it will go to the end node. Then the flow will be finished, and also this debug mode will be stopped automatically. Now the debug mode has been stopped, and also we can go back to the editing mode by click UC. So we are able to do some adjustment if there's something wrong happened during the debugging. If the debug passed successfully and there's no need to do any modification, then the service is ready to be deployed. So the last step, we need to build project, and after we build the project, in the home location of the UC, there will be a jar package generated, and this jar package can be used to deploy the service on the M2M platform. So this is the default location, and of course you can modify the location by here. Then click Finish.